Hello, good evening, everyone. My name is Femi, and I will be taking this session today, where we'll be discussing measures of spread and central tendency. Is everyone hearing me okay? Just a thumbs up will do if you can hear me okay.
Yes, we can hear you.
Good, good, good. Thank you. Right. So, yes, we will be talking about measures of spread and central tendency today. Thanks for joining this session. And I do hope everyone can see my screen okay as well. So what we're going to do is I will introduce some concepts to us. We'll talk about it. And then thereafterwards, we'll go on to SPSS and just, have a bit of looking around things, have a bit of a play around SPSS as well, just to know more about this concept that I'm going to introduce today. So measures of spread and central tendency are things that are quite popular in statistics that we use from time to time. And I reckon that majority of you will be familiar with the very common measures of central tendency. The mean, mode, and the median are the very common ones that we tend to use. The mean, as we all might probably know, is just an average. And then the mode is like the commonest value in a data set. And then the median is like the middle value in a data set as well. We would look at all of these things when we go on to SPSS to do a bit of practical, and we'll see how we can apply, each of these measures of central tendency. As I did say before, the mean is just basically aggregating all the values that you have in a data set together for a particular variable and just sort of finding the average. Take, for instance, you have 100 people, for example, in a data set, and they've all worked let's say 50 hours or variable number of hours, and you want to find the mean number of hours worked. If you have 100 people who have worked different hours, all you have to do is just sum up the number of hours that they've worked over the total number of people. That gives you your mean. The mode, for instance, would be the commonest hours worked by all of these people, and the median is the middle hour worked. So it may seem a bit abstract now, but hopefully when we go into the practical aspect, we'll probably be able to understand what I mean a lot better. Now, measures of spread or measures of dispersion is also the other concept to be looking at. We'll focus more on that in this class, in this theoretical aspect. And the measures of spread basically tell us how wide our data set is. You want to know how widespread your data set is. If you've just gathered some data and you are trying to make sense of the distribution of the data, you want to know, oh, are these numbers clustered together? Are these numbers very wide apart? You want to identify outliers in the data set, then you want to be looking at your measures of spread. And we will start with the very simple ones and gradually move upwards until we get to the slightly more complex ones. But hopefully shouldn't be anything too difficult today. If I'm going too fast, do let me know so that I can slow down, because I have the propensity to talk fast sometimes. I do apologize. Now, the first concept we'll look at is before we get into the first concept of the range, take for instance, as I did say before, the measures of dispersion or measures of spread. Dispersion is just from the word disperse, how widespread something is. It helps you to understand the distribution and the behavior of the data. If you look at these two data that we have here, -10, -5, 5, 10, 50, the mean of this data is 5. And the mean of the one that is just next to it, 2, 3, 7, 8, and 5, is also 5. But I believe we can all agree that the data set itself, the numbers look very different, although they have the same mean. So this tells you, how useful the measures of dispersion can be. And in the first example, the range helps you to differentiate these two data sets very clearly. And we'll get into that very shortly. The range is basically one of the very easy, measures of central tendency. It tells you the difference between the highest and lowest values in the data set. So it's basically the highest value minus the lowest value. If you look at this data sets, this picture that we've got here on the right side here, the pictures might look a bit small. Let me put it in slide share mode. Hopefully that will be a bit bigger. Right. So we are looking at, if you look at this data set, if you look at where my cursor is, we are looking at the total number of hours worked by different people. And if you see here, you have 100 as the highest number of hours worked, and then you have 30 as the lowest number of hours worked. So 100 minus 30 gives you your range, 70. So it tells you how widespread the data is. But you need to be careful when working with the range, because if there are outliers in your data set, and what I mean by outliers is this: imagine if, looking at this data set that we have here, you have 30, 40, 50, all the way to 100. And out of the blue, from nowhere, you just have one singular one that is 1,000 hours worked. That's an outlier. So you might want to be careful there, because your range could be potentially misleading in that case. You understand? And I also reiterated it here as well. I mean, if you just have a random single point at 1,000, but majority of your data is between 1 and 50, gives you a range of 999, which probably doesn't make a lot of sense. Telling you that there are potential outliers in your data set, and you should be looking at your data a bit closer. Again, at the end of this talk, we will go on to SPSS and we'll have a look through all of this concept. We will work with actual data to generate some of these figures, so that we have some practical experience of what it looks like working with these figures. Now, another important measure of spread that we use also is something called percentile. I know that it's something that you have probably come across. For those who are into medical practice, you might have heard of this very commonly. For those who have taken exams or tests in the past, and then they just tell you that, oh, you are in the 75th percentile, you're in the 60th percentile, or you're in the 20th percentile. What does it mean? So it's quite straightforward. The percentile is just a value that has a certain percentage of scores below it. So take, for instance, let's say we have an X or Pth percentile. It's just the value with P% of observations below it. So if I take a test, for instance, or if you take a test, and they say you are on the 60th percentile when you take that test, it simply means you have 60% of people below you. It means you have scored more than 60% of people, and then 40% of people have scored better than you. So it's quite straightforward. If you have, if the 75th percentile on the test was 120, it simply means that if you scored 120 on the test, you have scored better than 75% of test takers. If you are on the 90th percentile, it simply means you have scored more than 90% of the test takers. So it tells us the position of a data point sort of within the data set. Now, the 25th percentile is also called the first quartile. The 5th percentile, the 50th rather, because that's in the middle, is generally the median. And the 75th percentile is the third quartile. Now, there is a calculation we do to find the difference between the third and the first quartile, and we would usually call that the interquartile range. And we'll get into that concept very shortly as well. The interquartile range basically gives you information about the middle 50% of the data. So imagine you have gathered data, you have 1,000 variables from sort of 1,000 different people. You want to know how spread the middle 50% are. How are they clustered? How different are they from themselves? So the interquartile range essentially gives you that information. So it gives us the range covered by the middle 50% of the data, and it's quite very easy to calculate. All you have to do is arrange the data initially in increasing order, so from the lowest to the highest, and then you find the median. And the median is the middle figure. So the median essentially divides your data. Do you get? And when you find the median, your median splits your data into two equal halves. So you have the top half, and then you have the bottom half. Let me go into this diagram for better illustration. So this probably gives us a lot more clarity. So if we look at this data set that we've got here, we have these numbers, we can see that they are arranged in increasing order. And we have 1, 2, 3, 4, 5 in one half, 1, 2, 3, 4, 5 in another half. The median of this data set is 53 plus 55, this 2 over 2, that gives you 54. Now, if you want to split this data, if you want to find the interquartile range here, you split this data set into 2 equal halves. You have this lower half here, and then you have the upper half here. The midpoint of this lower half, that's your Q1. And the midpoint of your upper half, that's your Q3. You can also say this 58 here, this Q3, is your third quartile.
Yes, for cutting you short. Yeah, it appears we are seeing a different screen.
Oh,
yes, the screen has not moved from the range slide.
From range.
Still in PowerPoint.
It's still stuck on. It's still stuck on range.
Yes.
Right. Oh, sorry about that. Let me. Can you see a different screen now?
Yes. Yes.
Yes. Okay. So you can see a screen that says lower half, upper half, isn't it?
Sure.
Good. All right. So I'll just start all over again. So let's take a look at this data set from 45 to 80. We are trying to find the interquartile range for this data set. The first thing you do is you have to arrange the data set. You have to arrange the numbers in ascending order. Okay, so from the lowest to the highest. And then you have to find the midpoint of the lower half and the midpoint of the upper half. Now, in this data set here, for instance, we have 10 numbers, so we can split them easily into 2 equal halves. So we have 5 in each half. Now, the midpoint for the lower half, that's 52. That becomes your Q1. You can also call it the 25th percentile. You can also call it the first quartile. So that's Q1. Now, the midpoint of the upper half is 58. You can call that the 75th percentile. You can also call that the third quartile. And your interquartile range is just essentially Q3 minus Q1. So it tells you how far apart the data set is, the middle 50% of the data. It tells you how far apart they are. And just to use this to illustrate further, we would normally introduce the concept of something we call a box plot. It's very similar to, you know, this initial slide that I showed you previously. Can you see a slide change now? Can you see a box plot?
No, not yet.
Okay.
No, not yet.
Let me put that on
Now,
there.
yes.
Can you see
Can
it
you
now?
exit presentation mode and go again? Yes.
You can see it now. Yes, we can.
So you can see the box plot now.
Can you use the full screen from that side? Maybe that would help us to, you know, when you change the slides for us to, we can see
Yeah,
the change.
I'm not exactly sure why that is happening, but I think we'll just go ahead with the but I mean, since you guys can see it now, so we'll just continue with this one in that case. So this is a box plot. Now, let's assume that you have a data set that is spanning from here all through this place. You have your median, the middle point here. You have your first quartile or 25th percentile. You have your Q3, which is the 75th percentile or the third quartile. Your interquartile range, we have said previously, is basically Q3, that is this one, this higher one, minus Q1. That gives you your interquartile range. Now, there is a way we use interquartile range to also identify outliers. You know that we talked about the concept of outliers when we discussed about the range, that, you know, sometimes you can have a random value that is just exceedingly higher or lower than the other values in the data set. And you need to be able to make sense of the data when you're gathering the data. Now, with the interquartile range, if you want to find out what the outliers are, all you have to do is this. You take the first quartile, that's Q1, minus 1.5 times the interquartile range. Any figure that is below this will be treated as an outlier. And you also do Q3 plus 1.5 times the interquartile range, and any figure that is above this will also be treated as an outlier. So this gives you sort of a range. So you expect your data set to span between here, Q1 minus 1.5 times MQR, to here as the upper limit. So anything below this and anything above this will be treated as outliers in your data set. Now, do you want us to go into SPSS and do a bit of, some sort of practical work before we go on to standard deviation? Or do you want us to talk through all of them first and then go on to SPSS afterwards? Which would you prefer?
I think we finally finish all of them.
Okay, so we should go through all of them and then we'll just go on to SPSS afterwards. Okay, good. Fair enough. Right. So let's talk about standard deviation. Can you see my screen, the new one on standard deviation?
Yes.
Good. So standard deviation is usually, denoted with the Greek symbol sigma. And again, standard deviation is also part of the measures of dispersion and measures of spread. And it tells you how the data is spread about the center of a distribution. You want to know how far these observations are from their mean. So imagine you have a data set. If we look in this curve that we have below, you have a data set. This is the normal distribution curve. And the mean of this data set is here, 0. You have data to the left, you have numbers to the right. And you want to know how far apart the numbers are from the mean. That is when the concept of standard deviation comes into place. Now, 68% approximately of data will be within one standard deviation of the mean. Now, when we say one standard deviation, I already mentioned to you that this symbol here, sigma, is the symbol for standard deviation. It's just the Greek symbol to denote standard deviation. And the numbers can either be to the positive side or to the negative side. It doesn't really matter. But all you have to know is it's one standard deviation away from the mean, either to the positive or to the negative. So 68% of data gathered will fall within one standard deviation of the mean. And all we did to get that 68% was to add 34.1 plus 34.1. Now, how do we find out the data that is within two standard deviation of the mean? We just add up 13.6, 34.1, 34.1, and 13.6. Within 3 standard deviation of the mean, we add up 2.1, 13.6, 34.1, and we'll do the same thing on this other side as well. So as I said before, 68% of observations generally fall within one standard deviation of the mean. 95% will fall within 2 standard deviations of the mean. And approximately all of the rest of the numbers, all of the data set entirely, will typically fall within 3 standard deviations of the mean. And something closely related to the mean is another concept we call the variance. To the standard deviation, rather, is another concept we call the variance. It's also one of the other measures of spread. It also generally gives you how far out, how far out the data is, how spread the data is. And you can use the variance to calculate the standard deviation. So standard deviation is basically the square root of your variance. It means your variance is going to be the square of your standard deviation when you're doing a calculation, basically. Touching on standard error. Now, there is a tendency to confuse standard deviation with standard error in some cases. And I'll explain what standard error means. Now, imagine you take repeated samples from a population. Maybe you have 1 million people in the population. Someone goes there today, samples 1,000 people, gets a mean. Another person goes there, person B goes there tomorrow, samples another 1,000 persons, gets a mean again. Person C does the same thing, person D does the same thing, person E does the same thing. And that is done over and over and over and over again. Now, when you find the mean of all of those means from different people, that gives you your standard error. I would re-explain that in a different way. So what the standard error helps you to do is it helps you, decide or determine how close is your sample mean, how representative is this sample mean of your general population. If you have a standard error that is really large, a very high number of standard error, large number, you start to wonder that is it possible that this sample that I've taken, this sample mean is very different from the actual population mean? Is my sample representative of the actual population itself? That's a question you should begin to ask yourself. And another example, if we sample a group of adults and measure their blood pressure, if we take random samples from the same population of adults 30 or more times, ideally would expect those means, the means gotten from those random samples, different ones, to be quite similar. And if they are quite similar with low standard error, it means they are likely to be the population mean. But if they are very dissimilar, you have a high standard error, then it's very unlikely to represent the population mean in that case. And you should start to wonder whether or not there might have been some sampling error or some other errors along the way. As I did say before, a high standard error indicates that the sample means are widely spread around the population mean, and your sample may not closely represent the population. And if the standard error is low, probably tells you that, okay, your sample mean are closely distributed around the population mean and is likely to be more representative of the population. If you have, say, 1 million people or 10 million people in the population, and then you go on and you take a sample of maybe 10 people or 15 people or 20 people, there's a very high chance with that small sample size, you would have a very high standard error. And I mean, if you also look at it on the surface, sampling 20 out of 1 million people, it's very likely that what you will get will not be representative of the actual population itself, because that's a really small sample size. So some statisticians will try to make sure they're able to get small standard error by increasing the sample size, have a sizable amount of people, sizable amount of sample, and then you're likely to have a lower standard error and something that is closer to the population mean. So I've been talking a lot. I think some of these things will make sense if we actually do a bit of calculations, a bit of practical as well. Because I mean, I'm not really keen on us learning the manual calculation aspect of it, the mathematical aspect of it, because I mean it's possible, but in practice you'll probably be using more statistical tools and software to do all of these things than actually doing the manual calculation yourself. So I reckon most of us have SPSS installed. Am I right or wrong? Because I think this is an SPSS class. Am I right to assume that we have SPSS installed? Just give me a thumbs up so that I will know. Good, good. So let me share my SPSS screen. Just before I do that, do we all have access to the data sets in the Google Classroom? Good, because we are going to be working with one of the data sets there. So I'll just tell us how to get there. I'm going to share the whole of my screen. Good. So let's launch the SPSS. And if you go onto your Google Classroom page and you click on classwork, I believe there is a part there that says data sets. If you scroll to the bottom. Yeah. Are we there? If you are there, just give me a thumbs up. Good. So we'll be working with this resident doctor's Excel sheet. So if you're able to download that on your computer, you can do that. And then we can go on to SPSS to import it. So we'll just have a bit of a play around the variables there, the numbers there, and then we can just talk a bit about it to try and make sense of some concepts. So to import it, I already have this on my computer anyway, so I'll just come to File, Import Data. We are importing an Excel sheet, so I'll click on Excel. It's in my downloads, and that's it. And I'm just going to open that. Good. Okay. Right. So have we all managed to import the residents Excel sheet to our SPSS? If you're having any trouble doing that, just let me know so that we can brainstorm and see how to resolve it.
Hello, may you please repeat the whole process again?
So have you downloaded the resident Excel sheet, or do you know how to get there?
I have opened the Excel sheet. I'm not sure how to download.
Okay. So if you come to the classwork, let's see.
So under classwork, you should have data sets.
Yeah.
The data sets is one of the topics. You might need to scroll down a little bit to get to it. But data sets has all the data sets that we're using in class.
So once you get to the data set and you see resident XLX and then you open it, then you click on File, you can see Create a Copy, and you can download a copy. If you tell me where you are, then hopefully I can talk you through how to get here. Are you stuck on any stage?
I can see the resident doctors.
Good. So when you see the resident doctors, just click on it to open it.
Yes, it's open.
So if it's open, click on File. So File is to your top left corner. Can you see File?
No.
What's at the top of your screen? Can you see a section that says File, Home, Insert, Share?
No, I can't. I just clicked on it and it just opened.
So if it just opened, you should be able to save a copy. You should be able to either save or download a copy.
It looks like mine doesn't have that option. There's an option to open with. Oh, okay. Okay, now I have opened. It's fine.
Okay.
Sorry. Okay, now I can download into Excel.
Now you can
Okay.
download it, yes?
Yes.
Good. So after downloading it, to import into Excel, to import into SPSS rather, if you just click on File and you click on Import Data and you click on Excel, then you have to go into the folder where you have stored the downloaded resident doctors document, and then you just click on it and you click Open, and that should open it for you in SPSS. So ideally you should have this page, a page looking like this. So this is my own SPSS page. If you are at that point with your data set imported into SPSS, just give me a thumbs up so that I know, and then we can go ahead. If you are struggling to get there, let me know. Good. So I have 2 thumbs up so far. Does it mean 34 others are not there yet? Okay, so for those of us, someone asked the question and said, for those of us who are yet to install SPSS, is there a class or video to guide us on how to install? So if you literally go online and just type IBM SPSS, I think I saw the link on the Google Classroom group. I think I saw the link. So Dr. Abioye must have posted it on the Google Classroom on how to, I came across it sometime today on how to download SPSS. So, but if you, let me see if I can get the link for you. So I'll just paste it in the chat. So I'm just going to paste this in the chat. So I've pasted a link in the chat. So when you download initially, you get sort of a free trial period. So you should be able to play around with it to try and learn how to do a few things as well. All right. So moving on. If we want to, let's walk with the data that we have here and just play around with it for a bit, checking the concepts that we've learned earlier on. So if you come to analyze, this is your SPSS page. You have all of the data, from the data set that we imported. You have everything here already. And we want to try and, make sense of this data. We want to try and see a few things. So if you click on analyze and you come to descriptive statistics, and you click on frequencies. So for this class this evening, let's use hours worked as the variable that we are interested in. We are trying to, make sense of that variable. We are trying to describe that variable. We want to know the mean hours worked for the resident doctors. We want to know, the most number of hours that people worked. We want to know, we just want to be able to describe the hours worked by resident doctors. So that's what we'll be working with.
Please, can you just go back to how you got here? I missed that.
Okay. So if you look at the top of your SPSS screen, you will see some toolbars there. You have file, edit, view, data, transform, analyze. So we'll be working with analyze today. So if you click on analyze, you see descriptive statistics. You click on analyze, you see this drop down menu. And when you see this drop down menu, you see another side menu when you click on descriptive statistics, and then you see frequencies. So I want you to click on frequencies. And that brings you to this page. Are you there now? Thumbs up if you're there.
Yeah, it's fine.
Good. So you will see the variables from the Excel document that you imported. You see age. We are working with a data set about resident doctors. And there are different variables that were collected as part of this study. The age of the resident doctors, their mental health score, job satisfaction score, the workload score, their age category, their marital status. You have all of these different variables collected on resident doctors. But we are interested in the number of hours worked by the resident doctors. And we want to be able to make sense of that variable. We want to know more about it. So you click on hours worked. And then when you click on hours worked, you click on this blue arrow key here until hours worked appears under this variable section. So I'll do that again so that we see it. You just click on hours worked or whatever variable you're interested in. You click on this button, and then you see it jumps to this place here, to this screen. Now, you click on statistics. And when you click on statistics, you'll then be able to see different things that we can work with, different things that we can, talk about. So you have the central tendency section, the mean, mode, and the median, and the sum. You have the measures of dispersion, your standard deviation, your variance, the range, standard error of the mean, the maximum and the minimum hours worked. Now, let's start with central tendency. If we want to know the mean hours worked, that's, just saying we want to know the average number of hours worked by the resident doctors. You click on that checkbox there, checking mean. If you want to know the median hours worked, so let's say they arrange the data set and you want to know the hours worked in the middle, the median hours worked, you click on that. If you want to know the most common number of hours worked, so let's say you have 100 resident doctors, maybe 10 of them have worked 30 hours, 15 of them have worked maybe 32 hours, but we want to know the number of hours that most of them worked for. We click on the mode and then click continue. So we are working with measures of central tendency to begin with. We are not working with measures of dispersion yet. And when you click continue and you click OK, it then gives you an output table. So this is the output table for SPSS. So to make sense of this table, it's telling you that there were 161 recordings. That is, N is equal to 161. 161 people, 161 resident doctors told us how many hours they worked. We did not have any missing variable in that data set. This is the average number of hours worked by resident doctors, 71.16 hours. And to find this, if you want to calculate it manually, all you have to do is sum up this total number of hours worked over N, 161 resident doctors. That will give you this mean, 71.16. Now, if you want to know the commonest number of hours worked by the resident doctors, then that is this one, 50. So it means that majority, most residents worked 50 hours. And if you want to see this very clearly, if you want to make sense of this further, you see this frequency table at the bottom here for hours worked. If you look on the 50 section, 50 hours, you'll see that 31 resident doctors worked for 50 hours. You wouldn't see any other one as high as that. The next one to it is 70 hours worked by 24 resident doctors. So 31 resident doctors worked for 50 hours, making 50 hours the commonest number of hours worked by resident doctors, and that gives you your mode. Now, I want you to know that sometimes you can have two modes. So you can have a bimodal data. So it means if, for instance, 31 people worked 50 hours and 31 people worked 70 hours, then that's bimodal. It means you have two modes. But in this case, this is unimodal because just, 31 people worked 50 hours and we have nothing else as high as that. 19.3% of the residents, 31 people, worked for 50 hours. So that helps you make sense of the meaning of mean, mode, and median up to an extent. Median may not be so useful in this case because, it's essentially just the middle, just the middle value really when you arrange the numbers in ascending order. But in this case, you might find the mean and the mode, a lot more beneficial because you want to know, on the average, how many hours resident doctors work in, say, Kano State Teaching Hospital? They work an average of 71.16 hours. Oh, what is the number of hours that most resident doctors work in that hospital? Oh, most of them tend to work for about 50 hours. So you're able to give those answers. Now, if we go back to our the page where we have our variables again, our data set. Now we want to see the measures of dispersion. We want to look at, the standard error. We want to look at the standard deviation. We want to look at some other concepts. So we'll come back again to, before I get to that, did anybody struggle with, finding the mean, mode, and median from that data set? on SPSS, for those who have SPSS installed? Did anybody struggle? Was anybody able to do it successfully? If you did, just give me a thumbs up. So someone, Unachuku seems to be struggling. What part did you find challenging? You can unmute yourself and just let us know so that we can see how to work around it.
Yeah, I've downloaded the software, but I don't know like how I'm supposed to move from there.
Have you installed the software?
Yeah, I downloaded, but I know it's installed, but I don't know like what I'm supposed to do next.
You are supposed to create an IBM account, ideally. It should tell you a section where you should create an IBM account. And if you create an IBM account, they should offer you a trial period of about 14 days where you should be able to do all of these things. So if you open your SPSS, as soon as you've installed it, just open the SPSS itself, and it should give you the option of creating an IBM account.
Okay.
Elizabeth said she was unable to import the file. What aspect do you need help with exactly, Elizabeth? Have you downloaded the file?
Yes, I have, but I couldn't find it when I go to file and to import it on the SPSS, so I can't find it on my system, even when I go to where I saved it.
Okay, so you went to where you saved the Excel document. Did you see the document there?
No, I did not.
Right. When you save a document or download the document on your computer, which folder does it go to? Does it go to downloads, or where does it end up?
It goes to download.
So are you currently able to see the document in your downloads?
Yes.
And when you click on import and you click on Excel, you don't see the document anymore from SPSS.
Yes, I don't.
Oh, that's a bit confusing. Can you share your screen? I'm going to stop sharing my screen. If you can share yours, and then hopefully we can work around it.
Okay. Can you see my screen?
Yes, I can see your screen.
So when I go to
File.
Yeah.
So open downloads where your downloaded documents are. Scroll to the side. Let's see.
I think she clicked on folder.
It must have been saved in a different place entirely if it's not here.
I think she clicked on folder.
where? Sorry, where is the folder?
I guess you change the file type.
I think you clicked on folder.
This file of file.
That place where they wrote file.
Yes, just
File.
Cancel that
On the
file.
Oh, she
Okay.
clicked on folder.
Yes,
Yeah, I didn't
where
catch
you
that.
have file.
File.
Click on, no, not that one. Where you have that file
File,
written. Yes.
Yes, click on that file.
Okay.
Import data,
Import
All right.
Excel.
Thank you.
Excel, and then
Yeah.
look in the place you downloaded your documents.
Still giving me the same.
Scroll to the side. Yeah, there we
Okay.
go. Yeah, resident doctors. Open.
Okay, thank you.
It means it didn't finish downloading.
So you probably have to re-download it again.
Oh, okay. Okay.
I mean,
Thank you.
thankfully, you guys will have access to the recording, so you should be able to rewatch these videos and then do these things on your own later on. For those who are having problems with some IT problems, I'm just going to plug my computer. Just give me a second. Okay, So I'm going to go back to sharing my screen. So that we can move
So I
on.
have the account. How do I, like, I don't know, what am I supposed to do next?
So you've opened the IBM account.
Yeah.
Have they offered you a trial period of 14 days?
Yeah.
Yes. So once they've offered you a trial period of 14 days, you should be able to use SPSS. So just open the SPSS app and then put in your details there, your login details.
Okay, I should open the downloaded SPSS app.
Yes.
I'm just trying to see something.
Do you want to share your screen?
Yeah. Let me share my screen. This
Okay.
thing is confusing me. No, why it's no moving?
Yeah, so share your screen.
Okay. 1 second. How do I share? Okay, I think I'll click on share. So yeah, I think it's showing me select my meetings, meet. Select, it says select window or screen. I don't know what.
So just share your entire screen so that the whole class is able to see the screen.
Okay.
Yeah. So the class will be able to see your entire screen, and then everyone can chip in and we can help you.
Okay. So click. Allow. Okay. So yeah, this is it. I don't know if you guys.
Good. So what's the SPSS app that you downloaded? Have you opened
So this
it?
is the account. So I don't know.
So
I should download.
Click on download. Yes. So you have to download SPSS.
Okay.
So when you download the SPSS, you'll be able to use just when you open the SPSS after downloading it, you will then be, so you need to be careful. Is your computer 64 bits or 32 bits?
64.
64, yeah. So just download the SPSS 64 bits. Once it's downloaded and you install it, put in your IBM login details, and then that should automatically give you the free trial. Okay.
Sir.
Right. So I will go back to sharing my screen. So just to clarify, were those of us who were, who have SPSS downloaded and were able to work with it, did we all manage to make sense of? Oh, Mukhtar has raised his hand. Yes, Mukhtar, please unmute yourself.
Okay. Hello.
Yes.
Please, I am trying to download the resident doctor's data, but it seems I can only save in PDF. Will that work while opening it in SPSS?
I doubt that would work. I'm not sure. Let me see if
because I open it in the Google Sheet, but the only option of saving and getting is in PDF.
Oh, that's odd. So SPSS doesn't let you import PDF documents. It's not part of the options here. So I don't think that's going to work, I'm afraid. That's a bit strange if you're only able to save in a PDF. I'm not entirely sure why that is. Are you able to share your screen with the class?
Okay, let me log in with the laptop and then.
Okay, are you currently on the phone?
Currently, yeah, on the phone while using the laptop for.
Okay,
but I can switch. I can switch.
Okay, just let me know when you're ready, and then we can have a look at it together.
Okay.
Right. So the rest of us will continue for now. So, we have been able to, get some information on the mean, the median, and the mode of the number of hours worked by resident doctors. We are working with Kano Teaching. We are working with Kano State Teaching Hospital. If we want to get a bit more information about how widespread the data is, we want to get more information about the number of resident doctors, the number of hours they worked. We want to see the distribution of the data, how widespread the data is. We'll do something similar to what we did the first time. So we'll just click on Analyze again, Descriptive Statistics, Frequencies, and then we have hours worked still there. For those of you who don't know how to put hours worked in this region, all you have to do is just come here, click on hours worked, click on this arrow, and then if you click on statistics, and this time around, instead of median mode, we'll leave just the mean. We'll click on standard deviation, we'll click on variance, we'll click on range, we'll click on percentiles, on quartiles rather, and then we'll click on standard error of the mean, continue, and OK. Now we have all of this information here. What does this mean? How do we make sense of it? So the mean, as we already established before, is 71.16 hours. It means if we average the total number of hours worked by Kano State resident doctors, if we find the average, we arrive at 71.16 for 161 doctors. The standard deviation is 18. So it tells us that some of the data sets, some of the number of hours worked are quite far from the mean. So if the mean is 71, you have some figures that are as far as 18 standard deviations away from the mean, which is quite high. And if you look at the variance, this is also, as I said before, quite similar to the mean. It's not very useful in this case. Variance becomes very useful if you want to do things like mathematical modeling, you want to do projections, then variance becomes useful then. Otherwise, not so much in this case. So if we focus on the standard deviation, we see that some of the values are as much as 18 standard deviations away from the mean. And if you look at the standard error, you see that the standard error is 1.4. As I explained to you before, what the standard error means is if you take a repeated sample from a specific population and you find the mean of each sample, and you take a sample, let's say 30 different times or 50 different times, with each sampling you do, you sample 100 people, you find the mean of those 100 people every time, and you then find the mean of all those means. That gives you your sort of population mean. Now, the standard error is how far from the population mean is your sample mean. So if I have done just a single sample of 161 people like we have done in this case, and the mean hours worked is 71.16, the meaning of standard error in this case is this 71.16 hours, is it truly representative of the entire population of resident doctors? How far away from the resident doctors population, the number of hours worked, how far away from that mean is the mean that we have gathered in this data set? That's what the standard error means. That's the information you are trying to get from the standard error. Now, if we come to percentiles, at the 25th percentile is 50 hours. What this means is, who can clarify what we explained about percentiles the last time? Does anybody remember, just to make the class a bit more interactive? Does anyone remember what this means? This 25th percentile and 50. If you do, just unmute yourselves and just say it.
It means that the first quarter of the data set, the score on that, for instance, the observation that represents the first quarter, that is the first 25% of the data, has 50 hours worked. So it means all those in the first 25% worked 50 hours and below.
Exactly. Thank you for that. So this simply means that for those who worked 50 hours, okay, for those who worked 50 hours, they have only worked higher than 25% of people. For those who worked 50 hours, which is the median, they have worked more than 71. For those who work 71 hours, they have worked more than 50% of the resident doctors. And for the oversabi resident doctors, or the very busy ones who worked 89 hours, they have worked more than 75% of all the resident doctors. Remember that I said that typically your percentile, the 50th percentile, will be the median. And if you come on here and you look at when we did our calculation for median, you will see that the value is the same thing. So 71, your 50th percentile, 71. Now, who can tell us what the interquartile range is going to be in this case? We want to find out, oh, the middle, 75%, or sort of the middle 50% of these resident doctors that have worked, what number of hours have they worked? Who can tell us what the answer is going to be? How far apart are they from themselves, this middle 50%? Any takers?
39 hours.
39 hours. Thank you very much. So it's just basically this 75, what you have in the 75th percentile, 89 hours, minus what you have in the 25th percentile, 50 hours. That gives you 39 hours. And if you look at it, I think we can agree that, just looking at it on the surface, if the same set of doctors in the same hospital are working 39 hours, gap from each other, then that's quite a lot. That's quite significant, isn't it? And again, when you look at the frequency table, so the good thing about SPSS is SPSS can show you this frequency table here. So this frequency table, what's the meaning of all this thing that you can see here? It means 30 hours, number of people who work 30 hours, 1 person. Number of people who worked 40 hours, 12. Number of people who worked 50 hours, 31, and like that, all the way down. Coming down here, we also have the range. And again, this gives you a lot of information in this case as well, because this is quite a large range. It's 70. So it's telling you that, people worked 70 hours apart from themselves. So one person has worked maybe 100 hours and one person has worked 30 hours. That gives you a range of 70, which is also significant in this case. So these are common tools that we use, measures of dispersion, measures of spread, to try and describe data, to try and make sense of data. Your mean, which is the average hours worked, your median, which is the middle number of hours worked, your mode, which is the commonest number of hours worked, and then your standard error of the mean, how representative of the population of resident doctors, how representative of the number of hours worked by resident doctors in this data set, how representative is that of the actual population. Standard deviation, if you have found the mean, before you can find standard deviation, you have to find your mean. So let's say the mean here is 71.16. Your standard deviation, how far apart are some of these hours worked by resident doctors from the central point, the mean? We discussed the range as well, which is basically the maximum value in the data set minus the minimum value. So one person has worked 100 hours at the maximum. One lazy resident doctor has worked just 30 hours at the minimum. So 100 minus 30 gives you the range 70. Percentiles. 25% of resident doctors have worked 50 hours or below. Or alternatively, you can say those who worked 50 hours have worked more than 25% of resident doctors. Those who worked 71 hours have worked more than 50% of resident doctors. And the, very busy resident doctors who have worked 89 hours have worked more than 75% of all the resident doctors. Now, I think there's another class where we would do things like comparing means. So comparing means, if you want to know, oh, what's the mean number of hours that has been worked by doctors aged in this category, or doctors aged 50 years and above, or doctors aged 70 years old, or doctors aged 26 years old, I think there's another different class that we're going to be doing all of that. So we'll be comparing means and all of those things. But the purpose of this class today is just to introduce us to this very simple but important concepts of measures of spread and measures of central tendency, and get us to walk around it on SPSS. Just play with it in your own time, and then you'll be able to make a lot more sense of some of the of the data set. Benjamin, can you speak? Yeah. Benjamin Ozia, please speak. You have your hand raised. Okay. Jerry Mbaka, I think you have your hand raised as well. So you can unmute yourself and speak.
Yeah, so I wanted to ask a question. When you say that, looking at the percentile,
yes,
that those who worked 50 hours actually worked more than 25% of the resident doctors. Is that 50 hours included in the 25th percentile? Because you said more than. My assumption would be that that 50 hours is the cutoff for the 25th percentile. So 50 hours and below.
Yes, you are correct. So 50 hours is included in the 25th percentile.
Okay, then for the standard error, I'm still finding it difficult to understand how it applies.
Okay.
What the standard error, how it applies to the data set.
So let me,
if you can just shed more light.
Okay. So let's say we have 10 million resident doctors in Kano, and we have 10 different statisticians or 10 different epidemiologists. 10 million residents, doctors, 10 epidemiologists. Let's assume you are one of the epidemiologists. I am one of the epidemiologists as well. If I go into that population of 10 million resident doctors and I gather data on the number of hours worked by them, let's say I sample 100 of those 10 million resident doctors. That is my own sample. I find the number of hours worked by this 100 people and I calculate the mean. If you also go to them and do the same thing, sample a random 100 out of those 10 million, you find out the number of hours worked by them, you calculate the mean. Let's assume 28 other epidemiologists or statisticians, they do this as well. If you find the mean of all of those different means from all 30 different people, that gives you that should give you an idea of what the population mean is. Is it clear up to that point before I continue?
Yes.
Now, because we know that in actual statistics, practically, if you are trying to be practical, it's not likely that because you want to, know the number of hours worked by resident doctors, 30 of you or 50 of you will now go into the population and take data from, 30 or 50 different times. That's unlikely to happen. But let's assume one person has now gone again. One person who is actually conducting the study has gone into that population, has sampled 100 people, and has found the mean number of hours worked. If we want to know how close that mean is, the sample mean, that's based on the sample that he has taken. If you want to know how close that mean is to the population mean, the population mean is the mean we get from the samples that were taken by 30 different epidemiologists. So if you want to know how close that one mean is to the mean that was done by 30 other people, the standard error gives you an idea of how close they are. If you have a small standard error, it is very likely that that single sample you have taken and that simple mean that you have gotten is likely to be representative of the population mean. If you have a high standard error, then it is likely that this singular sample that you have taken, this singular mean that we have, is possibly not representative of the population need. Some sampling error may have occurred. You may have perhaps sampled only doctors in one particular hospital, or you may have sampled only doctors in one age range, or you may have sampled only male doctors, or you may have sampled only pregnant doctors. So lots of things could account for that difference. Does that make sense so far? I have
a question.
Mukhtar Humphrey Rob. Yeah.
So I still have a question on the clarification of standard error, because there's usually a formula for calculating standard error, which is usually the standard deviation divided by the
root of the
mean. So how is that related to what you are explaining?
So the standard error mathematical calculation is just standard error over root n. So it's just the total number of people. So again, the mathematical formula may not appropriately explain the actual concept itself, but the best way to explain the concept, the best way to understand it is basically what I've just explained to you. Standard error, in summary, is just a measure of dispersion, a measure of spread that tells you how close your sample mean is to a population mean. That's the summary. Is it truly representative of the population? Is it not representative of the population? Now, the decision, as to whether your standard error is large or is small is not going to be covered in the scope of today's discussion, okay? But as I'm sure as we go ahead in these classes, you'll be able to decide, okay, this is when standard error is small, this is when standard error is quite large. And as I said, it's just basically knowing, have I done the right thing? Have I sampled? Have I done this sampling properly? Have I done this sampling appropriately? Is this sampling, if I conclude that, oh, resident doctors are overworked based on this sample size that I've gathered, is that representative? Is that true? Or is that untrue? That's basically the question you're trying to answer with the standard error. I think I have Mukhtar's hand raised.
Yeah. So
yes.
I want to share the screen to show you, but then I think it's better if there are questions directly related to this so that you don't read. My one is to show how to download the data set. So maybe after the questions, please.
Okay. I had one other hand raised. I think it was Thabiseng Motlohi.
Yeah, I think my question is answered. I just wanted to understand, when do we use the standard error and when do we use the standard deviation?
Okay.
But if I'm correct, my understanding is the standard error actually compares the sample to the population, while the standard deviation just measures the dispersion within that sample, not necessarily comparing to the population.
Yes. So the other way some people talk about it is this. Some people will say the standard error is like a standard deviation of means. So you have different means and you want to see how close or how far apart these means are from themselves. So some people will say standard error is like the standard deviation of multiple means, if that makes sense. Standard deviation is just standard deviation of the actual sample itself. Different variables within the same sample. But when you're looking at standard error, you're looking at multiple means, an aggregation of means, and you're then trying to make sense of it. So shall we go to Mukhtar's issue about downloading the Excel file?
Okay.
So
can I share screen?
Yes, please share your screen.
Okay. Okay. How it's coming up?
Okay. Oh no, so this is resident doctor CSV. The one I want you to download is the Excel document.
Okay. So it's
go to the
classwork screen.
Yes.
Classwork.
Yes.
Yeah, that's down.
Scroll down. You will see data sets.
This.
No. So scroll down further. I'll tell you.
Okay.
Yeah. So click on
Okay,
data
okay.
sets. Yes.
Okay,
Then click on
okay.
that resident doctors.xlx. Yeah. So that's the one you
Oh,
want to download.
oh, great. Thank you.
So you should be able to save that.
Be able to save this. Yeah.
So if you click on file,
okay.
and then click on create a copy, and then you can download a copy.
Yeah. Thank you. Download a copy.
Yes, and then you can download a copy.
Great, it's done. Thanks.
No worries. Does anyone else have any other questions or anything you want us to go through again? Anything that needs clarification, anything you want us to revisit? So someone said, what is the range of the standard deviation to judge if it's high or low? Remember that we said that, approximately 99% of the variables should fall, ideally in a normal distribution, should fall within 3 standard deviations. So if you are getting a standard deviation of 18 point something, so that tells you that this is quite far apart. This is quite a wide standard deviation. This is quite a large one, because you are reasonably expecting that if this is a normal distribution, approximately 99% of the data set, approximately 99% of them should fall within 3 standard deviation. And now we have done a calculation, and then we are saying, we are getting standard deviation of about 18. So that's quite a large one. And you start to wonder whether you probably have lots of outliers in that data set, or they are quite far apart from themselves. So yeah, the fact that you expect a 99% coverage within 3 standard deviations, and now you're having 18 standard deviations, should give you an insight as to whether or not that's appropriate. You can put your questions in the chat box, or you can just raise your hand. So for those who do not have SPSS installed just yet, I posted the link in the chat box. So you can just go on there, download either 32-bit or 64-bit, depending on what kind of computer you are using. I believe there's a different version for those who are using MacBooks and the likes as well, if I'm correct. And when you download it, you create an IBM account. When you create an IBM account, you install the software, and you should be able to get a trial version for about 14 days, which you can play around with. The full version, I think, is slightly expensive. So, but for those who can afford it, yeah, it's absolutely fine to go ahead and do that. So if you want to pay for the subscription. So if there are no further questions or any other clarifications, then I think we can end the class. I will post some homework, some things that we can work with on the classroom, so that we can, play about some of these variables, and then we can get to, use them, and you can be able to make sense of some of the data there. Yeah, so I will, Jerry.
Yeah, so I was just wondering, since we have some small time, are you able to just in a couple of minutes or 5 minutes walk us through this data set, how we could generate a histogram of that data, and maybe to add the line to see whether it's symmetrical or asymmetrical?
Okay, so I think, Jerry, yes, I do appreciate that. That's something that you're keen on, but that's outside the scope of today's learning, I'm afraid. So I believe there is another session for, graphs and, plots, line graphs, histograms, bar charts, and the likes. I think there's another session for that. Yes, Mukhtar.
So within maybe the short period of time, if I can try what you just did. I actually didn't know what was on. I joined late. So if you can walk me through, maybe I share my screen and others can also get a better graph, just that people like me lagging behind. Of course, we can go back to the recording, but then if there is time, we can just few minutes, please.
Okay, so you want me to show you how to, import the data and generate all of those things again, isn't it?
Yes, while I was like, I will be the one, then I under your direction. Then.
Okay, yeah, that's absolutely fine. So you can share your screen. Please be free to share your screen.
Better, good. Okay, I'm sharing already. Is it coming up? Okay.
Yes.
This is my SPSS. Okay.
So if you click on File,
okay,
import data, Excel. Yes.
Okay.
And then go to where you downloaded. It probably should be in your downloads.
Yeah, and download. Where is the? Okay.
So it should be arranged in alphabetical order. So
Yeah,
resident doctors, and then just
okay.
And click OK.
Okay. Okay.
So click on Analyze.
Okay. Analyze.
Descriptive statistics, frequencies. Click on hours worked. So go to the bottom. We are trying to look at hours worked by resident doctors. Click on that arrow. Click on statistics.
Okay.
No, statistics, yes. And then you can check as many boxes as you want. Mean, median, mode.
Okay, quartiles.
To check quartiles, no, there's no need to check percentiles. Just check quartiles.
Okay.
You can check percentiles.
Median,
check median, mode. Check the
Mhm.
standard deviation.
Okay.
Check the
Right.
range. Check the standard error.
Okay.
Click on continue.
Continue.
And then click on OK.
Oh, great.
So there you go.
Yeah, that's good.
So SPSS lets you either copy the image, save it as sort of copy it as an image, or sort of copy it as text instead. So whichever you prefer. So if you want to maybe impute or extract this and move it to sort of maybe like a Word document or a PowerPoint document, then you're able to do that.
Okay, that's great. Okay, like this, right?
Yes.
Okay. Yeah. So thank you.
All righty.
Yeah, feel more confident now.
Yeah, so I mean, I think it comes with practice. Just have a bit of a play around it. Just play with it over the course of the next week before the next class. And you probably will be able to even discover a lot more features, be able to see a lot more things. You probably will be able to even start to compare means before we have the classes on comparing means. So I can leave my email. Someone was asking me how to reach out to me. I'll just drop my email in the chat box.
Okay, thank you.
So you can always leave me an email. Yes. All right. So yes, we will call it an evening. Thanks for joining the class today. If you do have any other questions as you play with it over the course of the next week, you can always, keep those questions onto the next class, and hopefully we are able to address them. If you are still having any challenges or any difficulty with downloading SPSS or opening an IBM account, let us know on the Start Clinic classroom, and hopefully we should be able to help you out. Okay.
Yeah, I have a question.
Yes,
the student who just helped. Sorry, I want to ask, what's his name?
Mukhtar. That was Mukhtar.
Okay. Okay.
Can I go ahead now?
Oh, did you want to say something?
Yeah, I wanted to ask when the video for this class will be available so we can go over it again for some of us.
Okay, I would have to ask Dr. Adioye, the convener. I'm not entirely sure how long it takes for them to look through, edit, and post on the groups. I don't know, to be honest. I'll probably have to ask him.
Okay.
Yeah. Well, it shouldn't be too long, though. Shouldn't be too long. All right, then. Okay. Take care, everybody. And I will see you next time.
Thank you very much.
Thank you. Bye.
Bye.
Sorry, what about the student Muktak? I don't know if I can, how can I reach out to him? I don't know.
Oh, I have no idea. Don't even know if he's still on
But
this.
you can place a message on Google Classroom now.
Yeah, you can probably message him there.
Mukhtar, I don't know, who do you have his like the spelling? I don't know what I don't.
Maybe you ask a question on Google Classroom, you respond.
Sorry, MUKH.
Okay, okay, you are here. Okay, yeah. Let me send me your email.
Okay, it's there in the chat.
Thank you. Oh, wait. Trying to copy this thing quickly. Oh, this thing removes me. Just give me a second. Okay. So I'm just gonna reach out to you. Thank you.
Welcome.
Yeah. All right. Thank you so much.